Hello, I'm teacher Ivan from Wuna Educational Services, a teacher of physics and mathematics at Angel High School, Namaswa. We are still looking at the measurements in physics, and in this video we shall look at the density. We shall discuss what density is. We shall also look at the units of density, how we convert from one to another, and how we determine density of different substances. Let us start with the definition. Density is defined as the density of a substance is the mass times volume of the substance. Mass times volume of the substance. And from that definition, we can get both the formula for density and the units for density. That is, we say that density is equal to mass over volume, because the word per means divided by. Then unit means one. So mean that we are going to divide the mass of the body by one unit of volume. And that means that how do we get the units of density? From our formula, which is mass over volume, then mass is measured in kilograms, whereas volume is measured in meters cubed. And therefore, that will give us the units or the SI units of density as kilogram per meter cubed. So the units will be kilogram per cubic meter. Now, the negative shows that we are dividing kilogram by meter cubed. However, we can also measure density using other units. For instance, we can measure this time mass in grams. That is to say, our mass will be in grams and our volume will be in centimeters cubed. So that gives us another unit of density, which is grams per cubic centimeter. So those are the two major units of density. However, this is the SI unit of density. So, since we have two units, that means that we can convert from one to another. Let's see how we do that. Since the density is defined as mass, which is in kilogram, over volume, which is meters cubed. So when we divide 1 kilogram by 1 meter cubed, this is the same as dividing, because 1 kilogram is equivalent to 1,000 grams over 1 meter cubed is equivalent to 1 million centimeter cubed. So that means that if we are to divide, we shall end up with 1 kilogram per meter cubed being equivalent to 1 over 1,000 grams per cubic centimeter. And that means that whenever I'm changing from kilogram per cubic meter to grams per cubic centimeter, I should divide my values by 1,000. Then let us see. If we multiply through by 1,000 on both sides, that will give us 1,000 kilograms per cubic meter being equivalent to 1 gram per cubic centimeter. That is, if we multiply by 1,000 by 1,000, we end up with this. And that means that 1 gram per cubic centimeter is equivalent to 1,000 kilograms per cubic meter. And therefore, when converting from grams per cubic centimeter to kilograms per cubic meter, we multiply by 1,000. That is how we convert units of density. Let us look at our last part, which is the determination of density. How do we determine density of different substances? Let us start with the density of solids. In our previous lesson concerning volume, we saw how we get volume. And also, when we're looking at mass, we saw how we get mass. And remember, density is derived from mass and volume. That means that whenever you think of getting volume, first think of how you get the mass and the volume of the substance. So the mass of a solid is gotten by measuring using a beam balance. And then if the solid is regular, we shall get the volume by measuring the dimensions and using a suitable formula for volume. That is if the solid is regular. But if the solid is irregular, we shall get the volume by either displacement method or the overflow Carnot method. And then we shall determine, or we shall calculate density using the formula of mass divided by volume. For a liquid, we shall get the volume of a liquid using a measuring cylinder. We shall get the mass of the liquid by first of all weighing the mass of empty dry container, and then we weigh the mass of the container with the liquid and get the difference. Then after getting our mass, we divide by the volume we gotten using the measuring cylinder. So that is all about density. Maybe before I summarize, there is also density of mixtures. For instance, I add milk in water, or I pour some water in milk, I get a mixture. So how do I get the density of that water-milk mixture? I'll get the mass of water, the mass of milk, and add them. Then the volume of water plus the volume of milk. So I'll get the density of the mixture as the total mass of the two over the total volume of the two. That is how we get density of the mixture. The applications of density. Density can be applied in a lactometer. That is the instrument we use to determine the amount of water in the milk. It can be also applied in determining the air to be used in a hot air balloon, because we need a less dense air, so we shall determine which air to use using or basing on density. We can also use density to determine the purity of substances, since they have specific densities. If it's water, you know that the density of water is 1 gram per cubic centimeter. Therefore, anything without 2 or beyond or less 1 gram per cubic centimeter is not pure water. So we can determine the purity of substances using density. And we also determine the substance itself, because you might have a liquid, but you don't know whether it's water, alcohol, or anything. So we can determine the substance using density. Then we summarize with the factors that affect density. Density is affected by temperature, because when you heat a substance, it expands and its volume increases, which in turn decreases the density, because the volume is inversely proportional to density, meaning that increase in volume will reduce the density. Therefore, when you increase temperature, the substance expands which increases the volume, but in turn decreasing the density. Then the other factor of density is pressure, whereby also pressure will affect the volume, hence affecting the density, and also the number of molecules. You know that the number of molecules affect the mass and also affects the density. So those are some of the factors that affect density. Otherwise, we shall pause from here for this lesson. I'm teacher Ivan from Wuna Educational Services. Please search for Wuna Educational Services all over the social media platforms. Subscribe to our channels. Join our pages and groups on platforms so that we learn together. Bye-bye.